All right, so we've gone over the bullet pattern, multi-object bullet pattern. So again, I'm not going to delete these. I'm just going to comment them out. Okay, let's do that. Oops. All right. Okay, well, we're going to talk about the supplier pattern. Well, what's a supplier, right? Technically speaking, supplier is nothing but a simple interface that, like the name suggests, supplies a particular object to you. But the object doesn't have to be a single object. It could be, instead of calling it a supplier, you call it a generator. But the main name, the common name for it is basically a supplier. Let me just show you what a supplier actually is. And then I'm just going to create a package here. Okay. Let's create our supplier. Done. This is a supplier. Oh, don't want to make the same mistake again, so I'm just going to zoom in all the way. Alright, this is a supplier. Very simple, nothing too complicated. That's all that there is to it. But it's so beneficial, and why is that? Well, let me explain. Let's create this other class. Let's say ID manager. Okay. So the goal of this class is to basically, let's say, associate users with a name with an ID. Okay. So how do we? I'm going to create a hash map. User to ID map. Okay. So this is my class, which is ID manager. I mean, it doesn't really matter what it is. Just you'll see why I created this as an example. It'll make more sense in a bit. So what the ID manager does is that you give it a user, which is a username. In this case, let's call it a username. It creates a unique ID for the user and then puts that in the map. So it does basically this. All right. And then in the future, maybe it exposes that to you, meaning get user ID. So giving the username back to the class, you're basically able to get the ID for the user. Okay. So what's the problem with this class, right? It uses a UUID, and then that's static. I mean, it could be any other static method, right? It could be, instead of being a string ID, it could have been a long ID or double, yeah, where you generated the ID in this manner. Either way, it's you generating something. The class accesses the static method and then generates what it needs to generate and then puts that in the map. So it causes some issues. Most importantly, testability. So how would you test this class? How would you test that the UID is indeed generated and then got put in the map? Well, in this very use case, you can definitely obviously get the user ID here using your get method. But this is a very basic case. What if there was a way? What if there is no way for you to get this? Like, what if this wasn't here, basically, right? What if that wasn't a functionality of your class? What if this is the case? But you want to make sure you don't have access to the map. So you want to make sure that you can access the exact random ID generated by the UID. So you can do some kind of comparison in the test. I think it will be more clear if I create a class. Yeah. And this class basically has a constructor for those two values. Okay, so this is the case. You know, we can access to the string. You can access to the user object because that's what's being stored. So you want to make sure that a proper UID is being supplied to your user. So how do you test that? Well, you can't test it like that because once you get the user back somehow, you no longer have access to the way it was supplied into. So you can't really have, you can have access to the string, but you can have access to how that string was generated, which is a very important part of your logic here. Well, that's where suppliers come into play. So instead of having a UID, a static UID generator being accessed here, you basically supply your class with a supplier of that kind. Now, what does that mean? So I'm simply going to create a supplier here. I'm going to call it UID supplier. And this class is going to be, like you guessed, will be supplier of string. Okay. So instead of using this directly, now I'm going to have, now I want to have a dependency to it. You'll see. I'm going to have an UID supplier. And then here, perfect. So why is this code testable now? Well, because, too many parentheses here, I think. All right. Well, because I have full control over what the supplier can return. In the test, I can easily pass in a mock object of any kind or any string I want, because that's what the supplier is going to return. So I can, as long as the supplier supplies a string, I'll have direct access to it in the test. And I'm going to create a sample test here with the supplier, see what it does. All right, I turn the lights on, created our test class. Okay, so the test class is going to basically test this. Again, let's quickly go over why it's important. Because before using a supplier, you were getting the string directly from the UID class statically. So there is no way of you testing whether the string that you get is randomly generated in the class somewhere, or you actually get it from the UID supplier. You know, I could easily pass in so instead of doing this, I could be doing a very random UID here. UID is usually like something like this. You get the deal. So there's no way for you to actually test the validity of, I mean, it could be a valid UID, but you wouldn't know if it's a new one, you wouldn't know, you cannot test that. But through the supplier pattern, you can make sure that the UID that you get from the supplier is indeed being used in the test. Here's what we're going to do in the test. So we have our I'm going to quickly create a class here. Alright, so now I have my test ID supplier. I'm actually going to do this here. Okay. You don't want to do it, you know. I don't need this either. I need to use over here. Did you not add that in this? Oh, yeah. Just the supplier. Right, we're good now. Go back to our tests. All right. Oh, we have to create a username. Called test for now. And we'll have for testability, just for now. This will have to be public. And we add a username, and then I'm going to get check the ID equals username. Nope. That's it. Okay, so what does this test do? Create a test manager, ID manager, with our test ID supplier. So in real life, obviously, you would have a production ID supplier, but we want to test this ID supplier. So what benefit does it give us? It gives us the benefit of you knowing for sure that the ID being set into your user is indeed coming from whichever supply you provide, not from some random source. With the UID access statically, you can't really test whether you're getting that from the UID from the UID class, unless you use like Power Makito or any other like powerful tool that allows you to mock your UID. But there's other benefits to this as well, meaning in the sense that you can use supply can be anything. You don't need to change the class itself to basically change the behavior in the supplier. You can supply a different supplier to change the way the ID is being generated. So let's run this test. Passes. Perfect. Just for good measure, let's test the name. Perfect. So that's the benefit of using suppliers. It allows you to basically go around static dependencies, because those like static dependencies singles often are not very testable. So it allows you to bypass that and make them testable. And it allows you, the way I see it, allows your code to be more clean. So I don't like having dependency that are statically being injected somewhere, which is often the case with singletons. So it makes your code more clean, more testable, and I think more robust also. Mainly it comes from like a functional programming background, but Java 8 actually introduced suppliers also, and then there's Guava that supports these additional functional I guess improvements to Java also. You should probably go check it out. I'll leave a link in the description. Alright. I wanted to like go over some other benefits of it as well. So let's say here it's a simple example here, the UID, very simple. But what if the object you supply is actually super complex to create? Like it's, I don't know, 20, 30 lines of code. Would you rather have that code everywhere? No. You could technically have a method in your class, but what if that logic is being handled across your whole app? Basically, you can't actually create one method in the class that uses it, and then you can technically copy that method everywhere, but that's also redundant. So instead of having all of that, you can create one supplier class like this one, and put the complex logic inside this, and then have the supplier go around and then supply it with multiple IDs wherever it's being required. Again, the supplier doesn't necessarily need to just create stuff from scratch. You can maybe have other logic such as recycling stuff. You could have creating stuff from scratch. You could have creating stuff at different times depending on what's going on in your app. To better understand the benefit, I will actually try to use suppliers with our builder pattern example that we had before. So I'm going to call that car supplier. And then what's going to do is basically do what happens here. Okay, so you see now we have a builder pattern inside our car supplier. Again, depending on the size of your builder, even the way it is, I think it's super beneficial. Because look how simple it is now. What if I want to create the exact same car? Now let's add a couple more stuff here. Let's say set here, set here. I don't know. Set model E-class. I don't know. Okay, so I want to create a Mercedes car that was built in 1999, and it's E-class, fuel type gas, it's automatic. And then my main class, I want to create a whole bunch of them, right? I could either do a whole bunch of these, just copy paste them, or I could basically create a car supplier that just pumps those out. Boom. Car 1. Boom. So now whenever I need that, I can just use my car supplier. See the benefit of it? It's perfect. Thank you. I'm gonna upload this to GitHub. I'll do it right now while you guys are here. Alright, go check it out.